Okay guys, here's the review of factoring that we talked about in class today that I promised you. Okay? We talked about factoring binomials and trinomials and polynomials, specifically polynomials with 4 terms in them. Okay? So the first thing I want to review is binomials, several different options if you'll remember. The first option was where we had something like this, x squared minus 25. Okay? When we have x squared minus 25, you'll remember that this is the difference of 2 squared terms. When it's the difference of 2 squared terms, we end up with 2 binomials. The square root of the first term goes at the beginning of each. The square root of the last term goes at the end of each, and they just need opposite signs. Okay? Now, I want you to look at this one carefully for me. 9y squared minus 36. And you might be first wanting to go ahead and just factor it just as it is. But another thing that we talked about today is taking out the greatest common factor. While these are both squared numbers, if we divide out a 9 from each term, it makes the problem easier. Okay? So divide a 9 out of each term, and what we have left is y squared minus 4. Now y squared minus 4 is also the difference of squares. So from there, we can get our 2 binomials. One will be y plus 2, and one will be y minus 2. And remember, it doesn't matter which one goes where. This could be the y minus 2, this could be the y plus 2, because it doesn't matter what order we multiply in. Okay? So there's 2 examples of things you might see. Another thing we talked about today in class was a problem like this. X squared plus 49. Okay? While this is not the difference of squares, it is the sum of squares. And if you'll remember, the sum of squares is prime. Okay? This is not divisible by anything but itself and 1, which makes it prime. And we can't go any further than that, so we write prime. Okay? Another binomial that we talked about factoring today was a binomial that looked like this. X cubed minus 8. Now, this is a difference, but it's not of 2 squares. It is the difference of 2 cubes. Remember, we have a binomial and a trinomial. Okay? So when we go to fill in our blanks, cube root of the first term goes here. Cube root of the second term goes here in our binomial. And we get our trinomial from our binomial. Square the first term, and it goes here. First times the second, and that's the middle term of our trinomial. And then the second term squared is the last term in our trinomial. Okay? Whatever the sign of the original problem is the sign of the binomial. The next sign is opposite of that, and the last sign is a plus. Okay? Another example. 8x cubed minus 27. Okay? Once again, we're going to get a binomial and a trinomial. Okay? The cube root of this first term goes here. Cube root of the last term goes here, because this, remember, is the difference of 2 cubes. Okay? First term squared is the first term in my trinomial. First term of the binomial times the second term of the binomial is the middle term of my trinomial. And the second term of the binomial squared is the last term of my trinomial. Whatever the sign in the problem is this sign here in the binomial. The next sign is opposite. The last sign is plus. Okay? Now, another problem that we talked about today is a problem that looked like this. 125 cubed plus 1. Now you're noticing this is not a difference anymore, it's a sum. Now it's not the same as the sum of squares, because remember, sum of squares is prime. This is very, very similar to the difference of cubes. The sum of cubes and difference of cubes have the same pattern. Okay? Binomial, trinomial, cube root of the first term here, cube root of the second term here. First term squared, 25x. First times the second, 5x. Second term squared. What's the sign of the problem? That goes in the binomial. The next sign is opposite. The last sign is plus. Okay, same pattern for difference of cubes as it is for the sum of cubes. Okay? After we talked about binomials, we talked about polynomials with 4 terms. Okay? And we called that factoring by grouping. Right? We had a problem like 6ab plus 2a plus 18b plus 6. So when we factor by grouping, we only look at the first 2 terms. Okay? When we're looking at just the first 2 terms, I say, what out of these terms are they both divisible by? What thing are both of these terms divisible by? Well, they're both divisible by a 2 to begin with, but they're also both divisible by an a. So when I factor out a 2a, what's left is 3b. Divide this by 2a, I'm left with 3 and b. Divide this by 2a. 2a divided by 2a is just, anything divided by itself is 1. Okay? Then I just look at the second 2 terms. When I just look at the second 2 terms, I say, what are they both divisible by? And in this case, the answer is 6. When I divide this term by 6, I get 3b. When I divide this term by 6, anything divided by itself is 1. Now, the important thing for us to notice here is that both of these things that are being multiplied right here, both sets of parentheses, are the same. If they're not both the same, we stop, because this cannot be factored by grouping. Okay? But when they are the same, I take what I factored out of the first term and what I factor out of the second term here, and then what they both had in common, 3b plus 1, I write here. And that is my answer. That's what can be factored. Now, if you want to get real technical, both of these, actually from the very beginning, everything was divisible by a 2, and I could have divided that by a 2 at the very beginning. And so that would actually change what this would be. That would end up being 2 times a plus 3. And then, of course, this answer right here, 3b plus 1. But that's just taking it one step further. Okay, simplifying it one more step. All right, let's do one more of those to make sure that we are solid on those. X squared plus 12x minus 2x minus 24. So I just look at the first 2 terms. What's common in the first 2 terms? Well, both terms are divisible by an x. When I divide each term by an x, what I'm left with is x plus 12. Okay? Now keep in mind, my second parenthesis has to be what? It has to be x plus 12. Okay? So when I'm looking to see what these last 2 terms have in common, while I agree with you that they're both divisible by 2, what I have to factor out from each is a negative 2, so that when I divide a negative 2 into these 2 terms, what I'm left with is x plus 12. Now my 2 sets of parentheses are the same. So I take what I factored out of the first, what I factored out of the second, and then what they had in common. And that's my answer. Okay? So this is what we did in class today. This is a review of just what we did in class on Tuesday, November 26th. The next video will be the review or the teaching of factoring a trinomial that does not have a leading coefficient of 1. But very quickly, I forgot to do trinomials with a leading coefficient of 1, okay, because we did do that in class as well, all right? For example, one thing that we did today in class was something to the effect of x squared, plus 5x plus 6. I think this is as an exact example of what we did in class, okay? And what we said was, we have A, B, and C. A, B, and C. Remember, that's the standard form for a quadratic. Okay, ax squared plus bx plus c. So a in this case is 1. My leading coefficient is 1. And this is the way we're going to do things with leading coefficients of 1. Okay, we're going to say what multiplies to be c, and what adds to be b. Or in this problem, what multiplies to be 6 and adds to be 5. Well, 1 and 6 multiply to be 6. 2 and 3 multiplied to be 6. So which set of numbers should I use to add that will give me 5? Hopefully you see it's the 2 and the 3. And I can go straight to my two factors, x plus 2, x plus 3. Again, this only works with the leading coefficient of 1. Okay? So if we have x squared plus, how about 6x plus 8. How about that? Okay? X squared plus 6x plus 8, well, it has to multiply to be 8 and add to be 6. So the multipliers of 8 are 1 and 8 and 2 and 4. Well, again, I hope you see that it is 2 and 4. And that's all. Okay? Let me do one more. X squared minus 4x minus 12. X squared minus 4x minus 12. It has to multiply to be the last term and add to be the middle term. Multiply to be c, add to be b. Okay? Well, the things that multiply to be 12 are 1 and 12, 2 and 6, and 3 and 4. So which combinations of multipliers can I use to get a negative 4? Well, keep in mind that if it has to multiply to be negative 12, one of these numbers has to be a negative. That's the only way you can multiply two numbers and get a negative answer, is if one of those numbers is a negative. Okay? Because we're really only talking about two numbers here. So hopefully you see that it is x minus 6 and x plus 2. Now, in the previous examples, we said it doesn't matter where the negative goes and where the positive goes, like when we talked about difference of squares. Okay? It could be x plus 5, it could be x minus 5, it could be x minus 5 and x plus 5. So it doesn't matter in problems like this where the negative goes and where the positive goes. I hope that you see that the answer is yes. Okay? Because if I said x plus 6 and x minus 2, that would turn out up here to be x squared plus 4x minus 12. And that changes the problem. Okay? So it does matter where these, especially when they're different numbers like this, it does matter where the negative sign goes and where the positive sign goes. Okay? Like I said a minute ago, the next video will show you how to factor trinomials that do not have a leading coefficient of 1. Okay? And you can actually do these the way I'm going to show you here in a moment. There's just kind of a shortcut here when that leading coefficient is 1. Okay? So watch the next video, and I will see you later.